Hello, good day everyone. In this video, we will be talking about the chain rule. It's not the literal chain we're talking about. Here in basic calculus, we have this type of finding the derivative where we call the chain rule. Let's start. Okay. The chain rule is a technique for differentiating composite functions. And when we say composite functions, these are made up of layers of functions inside of functions. So, to give you the idea of the chain rule, it is just like peeling an onion. This is what it looks like on the outside, right? So, for chain rule, as we peel it away, it's just solving for chain rule. It's just like peeling away the onion or the onion. And there's still more to peel. Remember, when you peel an onion, as you peel it, there's still more to peel an onion. Some functions have many layers that must be peeled away in order to find their derivatives. So this is what it looks like outside, and this is what it looks like inside. And to give you the idea, when y is equal to f of g of x, remember that this is a composite function. For this one is labeled as the inside function, and that is our outside function. And solving for dy all over dx or its derivative, it is just equal to the derivative of outside function multiplied to the derivative of inside function. That's how simple it is. So if y is equal to f of g of x, then dy over dx is equal to f prime of g of x times g prime of x. Take note, f prime of g of x times g prime of x. Okay, so this is the derivative of the outside, and then copy the g of x multiplied to the derivative of g of x. This is the step. These are the steps. First, let's identify inner and outer functions. Second, derive outer function, leaving the inner function alone. And third, derive the inner function before we multiply them. Let's start with example A. Take note that x squared plus 1 is our inside function. If the inside function contains something other than plain old x, you must use the chain rule to find the derivative. And this one is our outside function. The, the y is equal to the parenthesis and then the cube. Okay, so as we derive that, we need to take note and follow the rules of differentiation. And this is our inside function again. As we solve this, dy all over dx is equal to 3, applying the differentiation rule or exponent rule. 3, and then 3 minus 1 is 2 for its exponent. And then we copy there x squared plus 1. After that, multiplied by 2x, 2x is the derivative of our g of x, which is x squared plus 1. Then, remember this label here. This is the derivative of the outside. Only 3 and then the squared, and then we just copied the function g of x. And then 2x is the derivative of the inside, labeled as the blob there, as you can see the animation. And after that, we simplify. 3 times 2x, that's 6x. And then we copy here the quantity x squared plus 1, quantity squared, and that's our final answer. This is our final answer. And for this case, Differentiate f of x is equal to the quantity of 6x raised to the power of 4 minus 2x squared plus 3 quantity 1/3. Okay, we need to be there is a caution here that possible mistakes ahead. F prime of x is equal to, look at how the process will go. 1/3 times the quantity of 24x cubed minus 4x raised to the power of negative 2/3. Do you think it's correct? What mistake did I make? You need to realize that one. If am I following the chain rule? Yes, it's not. I changed the inside function and did not multiply by the derivative of the inside function. Remember that the inside function here should be copied. So we should not derive here inside, and then we must multiply it by its derivative of our inside function here. Okay, to solve it, okay, that is the wrong way. To solve it correctly, okay, we follow this step. 1/3 times the quantity raised to the power of negative 2/3. Why is it negative 2/3? Because 1/3 minus 1 is equal to negative 2/3. And then we place it there inside the parenthesis. That's how we do the process. After that, multiply it to the derivative of this uh, expression inside. 6x raised to the power of 4 minus 2x squared plus 3. Its derivative is 24x cubed minus 4x. You can double check that one by applying the rule systematically. And therefore f prime of x is equal to 1/3 multiplied to, okay, we copy that one, times, what am I doing here is that I am factoring out their common factor, which is 4x, and then multiplied to 6x squared minus 1. If you are going to distribute 4x to that given expression here, that is just equal to 24x cubed minus 4x. So don't be shocked. After that, we simplify. That's equal to 4 over 3x. No? As you can see, 1/3 times 4x, that's 4 over 3x times the quantity of 6x raised to the power of 4 minus 2x squared plus 3 quantity raised to the power of negative 2/3 times 6x squared minus 1. As you can see, we can still simplify this equation by, as you can see, the negative 2 over 3 there, okay? We are going to place that on the denominator. Therefore, our final answer is 4x times the quantity of 6x squared minus 1. 6x squared minus 1 will remain on the numerator. And then our denominator will be 3 times 6x raised to the power of 4 minus 2x squared plus 3 quantity raised to the power of 2/3. And that is our final answer for this example. How about example number 3? Differentiate f of x is equal to 3x minus 2x raised to the power of 4, quantity raised to the power of 6. Again, we follow there the step. So that's 6, and then quantity 6 minus 1, that's 5 for the exponent. And then we copy the inside function, which is 3x minus 2x raised to the power of 4 times 3 minus 8x cubed. If you're asking why is it 3, the derivative of 3x is 3. The derivative of 2x raised to the power of 4 is 8x cubed, because 4 times 2 x raised to the power of 4 minus 1, this is our answer, 8x cubed. And that is the final answer. No need to expand that one. We can have that as our final answer because we're just looking for the first derivative. After that, we have another example. Differentiate g of x, which is equal to the square root of 3x squared minus x plus 1. Okay, we can make the equation like this. Remember that a square root is just equal to power of 1/2. Therefore, we raise all the expression here on the right side to 1/2. Okay, as you can see, what's inside the square root? So that should be the expression within our power of 1/2, or within the exponent 1/2, because we're not violating our rule when we do it like that. After that, g prime of x is equal to 1 half times the quantity, and then for the exponent, 1 half minus 1 is equal to negative 1 half. And after that, we copy it here inside. That's 3x squared minus x plus 1 times 6x minus 1, because 6x minus 1 is our derivative for 3x squared minus x plus 1. After that, we simplify 6x minus 1 for the numerator, and then we place this one in the denominator together with 2. So that's 2 times 3 times the quantity of 3x squared minus x plus 1 quantity raised to the power of 1 half for our uh, this in this case. And after that, as we simplify, so you can see 1 half can be expressed to square root. That's 6x minus 1 all over 2 times the square root of 3x squared minus x plus 1 for our final answer. And if you're asking, sir, can I stop here in this form? Yes, you may stop that on that form, but it is more concise, and it is more simplified as if we're going to express that one into its radical form. Okay, and then let's have example number E. Example letter E, I mean. Differentiate h of x, which is equal to negative 7 all over the quantity of 2x minus 3 quantity squared. Okay, remember that our h of x is just simply equal to negative 7 times 2x minus 3 quantity raised to the power of negative 2. Okay, I'm not violating a rule here because I changed my exponent to negative 2, and this is just equal to my first given. After that, we follow the rule 14. Why is it 14? Because negative 2 times negative 7 is positive 14 times the quantity. And then remember, our exponent will turn into negative 3 because negative 2 minus 1 is negative 3. We copy there the inside function, which is 2x minus 3 times 2, because the derivative of 2x minus 3 is 2. Okay, by applying the rule again of, of differentiation. After that, that's 28 because 14 times 2 is 28. And for our denominator will be this one. This. Okay, that's the quantity of 2x minus 3 quantity cubed. And that's our final answer. Okay, so let me stop with this example. If you are wondering, sir, where are the examples for trigonometric functions? For trigonometric functions, we will still follow the same rule. Okay, you can base it also on your book, but I'm going to send you a separate PowerPoint where there are examples for trigonometric functions. Don't worry about that one because I'm just giving you here the concept of how to solve it in a systematic way. Okay, thank you so much, guys, for tuning in and for listening. Have a good day and keep safe, everyone.